Hello everyone, welcome back to lecture series on M3 subject. Already we have started lecture series based on linear differential equation with a constant coefficient. Within that we are working on complete solution or general solution. Already I have uploaded plenty of the videos on complementary function. If you are interested to see this video, check in my playlist. So, and after that I uploaded plenty of the videos based on the short trick for finding the particular integral. Okay, so using short trick we can easily find out the particular integral. Okay, these are the very easy examples, gives us the 4 to 5 marks in our SPPU question paper. Okay, so without further ado, let's get dive into today's lecture. I'm gonna explain to you first of all the condition, then we go for some example. Okay, yes, already I explained for the exponential function. Okay, so maybe this one is the next condition, fifth number. Okay, we have to find out the particular integral using short trick. Okay, if function f of x, okay, if function f of x, which is in the form of x into v, okay, function is in the form of x into v, that means x into function with respect to or which contain x variable, okay, or v is the function of x, is the function of x here. Okay, is the function of x. Then we write particular integral, as we know that particular integral as 1 upon f of d into phi of x. Okay, so f of d we replace. Okay, there are some certain condition we need to remember for solving such examples. Okay, we have x into the v is the function of x. Whenever you get such a condition, so we modify particular integral. Okay, we modify particular integral as, now see that we have to take that x as it is out here. Okay, x as it is out here minus 1 upon f of d. Okay, we take x out here minus 1 upon f of d into f dash of d here. Okay, into multiplied by f dash of a d and 1 upon f of d into v it is remain here. Okay, so 1 upon f of d into v. Okay, 1 upon f of d into v, we have to keep this condition in our mind while we are solving this example. Okay, now see that it is not that difficult, it is one of the easy condition. So what we do here, we take that x minus 1 upon f of d into differentiation of f of d. Okay, so f of d is the given our auxiliary function. Okay, and phi of x, which is the right hand side. Okay, and phi of x means we are taking as a x into v here. Okay, yes, so 1 upon f of d into v it remain here. Okay, yes, we go for some of the example, then it will be the crystal clear for you all. Okay, yes, let's go for some of the example based on this property. Okay, so example, and v can be the function, of any function like a trigonometric, exponential, or any other function. Okay, yes, so consider example over here, d square y by dx square plus dy by dx plus y, which is equal to x into sin x. Okay, this one I consider here. Okay, this one is the function I consider here. So we have to find out the particular integral and a complementary function too. Okay, that means a complete solution. This is an important question asked several time in your university question paper. Okay, important for SPPU. Okay, so this one is important example. It is one of the easy example, nothing it is difficult here. Okay, so first of all we go for the complementary function. So complementary function, first we consider auxiliary equation. Okay, so auxiliary equation we are getting it from here, so d square plus d plus 1. Okay, so we are going to write auxiliary equation as d square plus d plus 1, which is equal to 0. Okay, so if you didn't understand how I have written this auxiliary equation, please go through my previous videos. I explained so many times, much more example in my playlist. Okay, see this how I have written. Double differentiation means d square, single differentiation d, and y means plus 1, which is equal to 0. Okay, so we have to find out the roots for this equation for complementary function. Now see that some of the equation, okay, some of the quadratic equation, this one is our quadratic equation in the form of D. Some of the quadratic equation has some complicated roots, okay, that generally we cannot define by their multiplication or addition. So we have to apply some standard formulas for finding the root. Okay, so one of the formula, you all are familiar with this. Okay, whenever if we have x square plus bx plus c which is equal to 0, this one is our standard quadratic equation, then we write its a root m as minus b plus minus square root of b square minus 4ac upon twice of a. Okay, this one is the standard formula for finding the quadratic root. So this is the equation in the form of x, and this one is the equation in the form of a d. Just x and d are replaced here. Okay, so compare both of them. We get the ax square means d square, the value for a which is 1, bx means d, okay, the value of b which is again 1, and c which is equal to 1, a1, b1 and c1. We got the three different roots. Okay, three values for ABC, not a root. These are the value for ABC that we have to replace it here. Okay, then we write m as a minus b minus 1 plus minus square root of b square 1 square means 1. Okay, minus, okay, minus 4 times a into c, 4 a into c, it is minus 4. Okay, upon twice of a, upon we write 2 times a means it is 2 here. Okay, go for further solving. Okay, so minus 1 plus minus 1 minus 4 which is a minus 3, square root of minus 3. Now see that whenever we get the square root of minus 3, there is a 100% chances that number is a complex. Okay, iota it is coming. Okay, so 1 plus minus square root of minus 3 divided by 2, we write minus 1 plus minus square root of minus 1. Okay, that means we write I square into 3. I square is, what is the value for iota square, which is a minus 1. This one is the standard form, okay, of a complex number. Okay, that whenever we get the iota, that means obviously there exists a complex number. Okay, iota square minus 1, that means I written minus 1 as iota square. Take iota out here, then we write 1 plus minus iota times root 3 divided by 2. Okay, that means 1 by 2 plus minus root 3 by I times root 3 by 2. Okay, these are the complex and distinct root. These are the complex and distinct root. Okay, so for finding the solution, we consider it is the with respect to a plus minus ib. What is the value for a, which is 1 by 2? What is the value for b, which is a root 3 by 2? Okay, the value for a and b it is here. Okay, and now see that as we have roots are complex and distinct, then we write it's a complementary function or a solution or complementary function as e raised to ax c1 cos bx plus c2 sin bx. Okay, yes, e raised to ax, e raised to ax means e raised to 1 by 2 into x, c1 cos, what is the value for b, root 3 by 2 into x plus c2 sin, what is the value for b, root 3 by 2 into x. Okay, this is our required complementary function. Okay, this one is our required complementary function. Just what I have done, I replace with the complete complementary function with the value for a and b, which is from our root here. Here this one is our complementary function. Now it is time to work on the particular integral. Okay, we are going to find out the particular integral using our given complementary function. So we know that particular integral can be written as 1 upon f of d into phi of x. Okay, but in this condition we have here x into sin x, x into sin x, then we write x minus 1 upon f of d into f dash of d as 1 upon f of d into phi. Okay, so this one is our required particular integral. So we are going to replace f of d as here d square plus d plus 1 as f of d. We are going to differentiate it here, and 1 upon this one d square plus d plus 1 and into phi. What is phi here? In actual x into phi, phi means a sin x. Okay, we have here phi as a sin x here. Okay, so replace all these values here in our particular integral. Okay, here I'm going to write the particular integral here. Okay, so particular integral as, let me write the given part first. Let's work with these values f of d phi in our given particular integral. Okay, so I'm going to write particular integral as x minus, okay, x as it is. Okay, as we have x into sine x as a phi of x, so I'm taking x out here, x minus 1 upon f of d, that means 1 upon d square plus d plus 1. Okay, 1 upon d square plus 1 upon f of d into f dash of d. F dash of d means we have to differentiate that f of d with respect to d, so we are going to write f dash of d as differentiation of a d square with respect to d, which is a 2 times a d. Okay, differentiation of a d with respect to d, which is a 1, and constant 1, which is it goes to 0. Okay, into 2d plus 1. Okay, this one is our required f dash of d. Okay, so complete these curly braces into 1 upon f of d, that means 1 upon d square plus d plus 1 into v. What is the value for v? Replace v as a sin x. Okay, replace v as a sin x here. Okay, so I just replace all these values here in our given particular integral. Okay, now we are not going to do anything changes over here. Okay, because we are going to solve it later on. First of all, find out the particular integral for 1 upon d square plus d plus 1 into sin x. Okay, yes, so we know one more condition. Okay, I'm going to write this condition. See here, guys. Okay, so whenever we have if f of x, I already explained this condition in my previous lecture. So if you want to see complete detailed video, you can check in my previous playlist. So f of x, which is equal to whenever we have sin ax plus b or cos ax plus b. Okay, whenever f of x is sin x plus b or cos ax plus b, then we write a particular integral as 1 upon f of d square. Okay, we write 1 upon f of d square into as a sin ax plus b. Okay, sin x plus b or cos ax plus b, and we replace d square as 1 upon minus a square, that means d square as a s minus of a square, that means we write 1 f of minus a square, f of minus a square sin ax plus b. Okay, this one is the particular integral. Okay, required particular integral. Now see that carefully how I'm going to solve this part. Okay, we are dealing with this part only. Okay, this one is the part we have to solve it first, then later on we are going for this one. Okay, yes, f of minus a square into sin x plus b. Now see that sin x and sin ax plus b, how can we compare? Okay, sin x and sin x plus b, sin ax plus b and sin x, I want to compare this. Okay, that means sin, we write x plus 0. Okay, that means we get the a which is equal to 1 here with the comparison, sin 1 into a plus 0 and b which is equal to 0. I got the a1 and b0. I replace, if a is 1, then minus of a square, minus of a square, that means minus of 1 square, we write a minus 1. Okay, and minus a square, we know that the d square. So wherever you found a d square in our auxiliary equation, d square plus d plus 1, replace as a minus 1. Okay, replace as a minus 1 here. Okay, I'm going to replace here in the particular integral. Particular integral is, okay, x minus, keep that term as it is, we are not going to change here, x minus 1 upon d square plus d plus 1. Okay, d square plus d plus 1 into 2d plus 1. Okay, bracket is complete. 1 upon, replace wherever you found d square as a minus 1. Okay, so I found here first term as minus 1, so minus 1 plus d plus 1 into, keep sin x as it is. Okay, so I kept that sin x as it is. Okay, this is our next term, minus 1 plus 1, it get cancelled here. Okay, so particular integral, it can be written as x minus 1 upon d square plus d plus 1 into 2d plus 1. Okay, and minus 1 plus 1 get cancelled, 1 upon d into sin x, we left here with the value 1 upon d into sin x. Okay, so as we have 1 upon f phi of x, 1 upon d into phi of x. Okay, 1 upon d into phi of x, we write integration of phi of x directly. That means 1 upon d means inverse proportion of integration. Okay, that means when we write this one in the form of integration, we take directly the integration of phi of x. Okay, this one is the standard form, already I explained in my previous lecture, so apply it here. 1 upon d means integration of a sin x. What is the integration of a sin x? Which is a minus of a cos x. Okay, so we write particular integral as x minus 2d plus 1 upon d square plus d plus 1, okay, into minus cos x. Okay, so what I have done, actually I taken the integration 1 upon d into sin x means integration of sin x. Okay, so I taken integration over here, okay, minus cos x. So take that negative sign out here. So I'm going to write particular integral as, okay, particular integral as that negative outside here, cos x multiply here x into cos x. Okay, cos x here, x cos x, that negative I already took it out here. Okay, so you don't have to take negative under bracket here. Okay, x into cos x minus it keep as it is, minus the sign here, 2d plus 1 upon d square plus d plus 1 into cos x. Okay, so that negative outside here. Okay, don't get confused. So we left here with the value x cos x 2d plus 1 upon d square plus d plus 1 into cos x. Okay, so we have to solve this entire term here. Okay, yes, first of all, what do? We are going to replace cos ax plus b as a which is equal to 1 here. Okay, similar like we done it here. What we have done here in our first part, f of x is equal to sin x plus b. Instead of that, you will get the cos x plus b. So cos x plus b can be written as, wherever you found d square, replace minus a square into cos x plus b. It is like this. So using above same result, we are going to change it here. Cos ax plus b, that means cos ax plus b, which gives a which is equal to 1 and b which is equal to 0. Okay, replace wherever we get the d square as a minus a square, d square as a minus of a square, that means minus of 1 square which is equal to minus 1. Okay, again do it here in this condition. Okay, so I'm going to write minus out here x cos x minus, okay, 2d plus 1, keep as it is, don't go for anything changes here. Okay, replace only whenever you have d square as a minus 1. Okay, so minus 1 plus d plus 1. Okay, minus 1 plus d plus 1, okay, into my cos x here. Okay, that negative I taken out here, that only left with here with the value of a cos x. Okay, minus 1 plus 1 get cancelled, so minus keep as it is x cos x, okay, minus time 2d plus 1. Okay, and we know that 1 upon d into cos x means it is a integration of a cos x as 1 upon d into phi of x, that means integration of phi of x. So we want the integration of a cos x, and integration of cos x we know that sin x. Now see that how easy it is, just follow the step guys, it is one of the easy solution. So multiply sin x under here, that means 2 times d into sin x plus sin x. Okay, I'm multiplying sin x under bracket here. Okay, so remaining term keep as it is, minus of x cos x as it is, minus times 2d sin x, okay, plus sin x. Okay, bracket complete. Okay, so minus x cos x minus 2 times derivative of a sin x. D sin x means d by dx of a sin x, and derivative of a sin x, it is a cos x. Okay, derivative of a sin x, sin x has a derivative cos x, and cos x has a derivative minus sin x. Okay, it is exactly opposite in integration. Okay, 2 times derivative of a sin x, which is a cos x, plus sin x, minus take it under bracket here, minus sin x here. Okay, this one is our required solution. Okay, so particular integral I'm going to write it here, multiply negative under bracket here, negative x cos x minus minus plus 2 times cos x minus minus plus sin x. Okay, this one is our required particular integral. Okay, and earlier we found complementary function. Okay, so add complementary function plus particular integral, we get the general solution. So do it guys by yourself. Okay, so you will get the complete general solution for this example. Okay, Yes, this is our complete solution. I hope you all have understood, guys, everything here. So I want you all to solve some of the example for your homework. Just a minute, I'll give you some examples here for your homework. So this one is the example x into v form. Okay, x into v form, d square y by dx square plus 4y. Important example from SPPU previous year question paper, asked mostly in previous year question papers. Okay, so we have to find out the complete solution or general solution. Keep this example for your homework, guys. Solve this example and let me know the answer in my comment section. This one is compulsory for you all. Okay, so I hope you all have understood my today's entire lecture, okay, which is completely based on the shortcut for finding the particular terms whenever we have phi of x as a x into v form. Okay, this one is a very much important shortcut for you all, guys. I hope you all have understood. Even after if you found anything difficult, let me know in my comment section, guys. Okay, so thank you everyone. Thank you for my today's lecture.